Welcome back to Cradle to Grave Algebra. In this short lesson, I'm just going to walk you through two problems and we'll solve them together. This will give you an idea of how word problems work. In this first example, we have Billy buys a pizza for $15 and several bottles of cola for $2 each. Now, we don't know how many bottles of cola he's going to buy. So, the next sentence, let M represent the total amount of money that Billy spends, and let W represent how many bottles of cola she buys. Well, Billy the girl, I suppose, which is fine. I just noticed that. So if M represents the total amount of money, and we're trying to figure out what M equals, so let's just write that down and say, M does equal something. And what does it equal? Let's break this thing down. We know that they bought a single pizza, or Billy bought a single pizza, because it's a pizza. So that A represents the one pizza, and that pizza was $15. So we know for a fact that $15 is part of this equation. So the amount of money spent is definitely $15, but they also bought cola. So we have to have an addition, so another term to this equation, or this expression. So several bottles of cola for $2 each. We know they're $2 each, but we don't know how many. So we can use the multiplication, the product of W, which represents the number. So it'd be the number of bottles of cola times $2. Or we can just represent it as 2 times W, as the problem tells us to do. Let W represent how many bottles. So $2 times how many bottles. If she bought 2 bottles, it would be $4. 3 bottles would be $6, etc., etc. We can go ahead and put these dollar signs on. You don't need to put the dollar signs on, but you must know that this entire right-hand side of the equation represents dollars. So either way works, as long as you know that they're dollars. All right, so that's the entire equation. That's it. So M is equal to 15 plus 2W. Now, let's just say Billy buys 6 bottles of Coke, right? So it's easy to figure out because all we have to do is plug in 6 for W. So how much money did he spend, or she? $15 plus 2, and instead of the W, we put the 6 in there. That's simple as that. So 6 times 2 is 12. I'll put that down here. Plus 15 equals M, and we're talking in dollars. So I'm going to put this equal to 15 and 12. I like to just double 15 and call it 30, subtract 3, but whatever. 27. $27. Do your math in your head or your calculator, but the answer is $27, and that's how easy it is. So that's problem number 1. Problem number 2 would be pretty basic too. I think you guys will pick it up quite easily. Let's start with a cube, and I'm just going to draw a cube like so. I'm not the best at drawing with these things, but I'm actually kind of impressed right now. So that's a cube. We're going to call this cube, it's going to be 5 inches. Now, I'm not going to put the little inches on there, but know that it's inches across. 5 by 5 by 5, up and down. So the volume of a cube, I think everybody should know that the volume of a cube is equal to the length times the width times the height. Or in this case, the length and the width and the height are all 5, so it's 5 cubed. Now, what if I was to tell you that there's a cube that's X inches shorter per side? How would you write that equation? So I'm telling you that a cube is X inches per side shorter than this cube here. So let's think about that. If it's X inches shorter, we can represent this cube. We can do, let me use a different color again. So it would be 5 minus X, but on each side. 5 minus X. We don't know what X is. X might be 2 inches. So if X was 2 inches, it would be 3 inches per side, right? So 5 minus X on every side. And now we still have length times width times height, but now let's do this out with the exponent there. So the volume equals the length, which is 5 minus X. I'm going to put that in parentheses because you have to here, times the width, which is 5 minus X, times the height, which is 5 minus x. You see the pattern here? They're all the same term, 5 minus x, 5 minus x, 5 minus x. So you could represent that easier if you just said 5 minus x to the third power. And you don't have to expand this out and do the multiplication. Leave it as this, because if I told you now, I will tell you that, hey, I want a cube that is 1 inch shorter than the one represented here with 5 cubed, which 5 times 5 times 5 is 125. Let me just write that out, 125 inches, right? So that's the answer with 5. Now I'm telling you, I want to find out what this other cube is. We'll call it V2 actually, so V2, because it's different than this volume here. So the volume 2, I'm going to tell you, hey, let x equal 1 inch shorter, right? So let's just plug that in. So we have our final equation here, V2 equals 5 minus x, but we know I was in the way for part of this equation, so I'm going to jump back in and start with where I think I left off, which was we have the final equation for V2, 5 minus x to the cubed. Now, if I tell you that, hey, x is going to equal 1, we could plug 1 into this equation here, this volume 1 or volume 2 equation, to get the result. Now, we know the result up here is 125, and so down here, because 5 cubed is 125 inches. So down here, instead of doing all this math out, this is a crazy math expression here. Instead of expanding it out, we can just plug in that 1 here and say 5 minus 1, and I'll try not to get in the way here, cubed, which 5 minus 1 is 4. I'll put that over here. So equals 4 cubed. We can get rid of the parentheses because it's only a single term, 4 in there, and 4 cubed is equal to 64. And that's it. That's how easy this is. I hope that this made sense to you. Do more practice problems, find problems online to do, and just practice, practice, practice. See you in the next lesson.